Folks, it is truly amazing what you have at your fingertips nowadays as an educator and as a student to learn about our world and other worlds. Now, I've got videos about the Mars 3D map viewer from ESRI, Environmental Systems Research Institute. That is a wonderful tool. This tool that I'm going to explain today is a different tool, but it is equally wonderful, and it offers many avenues for teaching about geography, astronomy, mapping, geographic information systems, themes of scale and distance, mathematics. This is the Mars Caltech High Resolution Viewer. As you can see here, you've got a lot at your fingertips here. For example, you've got different areas of Mars at the bottom here, so you can quickly scroll over to different bookmarks that are mentioned here in the bottom: Valles Marineris, Olympus Mons. We're going across the Valles Marineris right now toward Olympus Mons. And as we do that, you can see certain landforms on Mars. Mars is smaller than Earth, of course, but it has some mighty big landforms, including this one right here, Olympus Mons. So if we take a look at this, we've got some tools at our right side and at the left side. At the left side, we can create a bookmark. There are bookmarks already predefined for you at the bottom, but you can add your own bookmark if you wanted to say, well, this is the south view of Olympus Mons, for example. All right, super. Now we can go there at any time we want. But more importantly, let's take a measurement off of here, or about 400 kilometers from the top to the base. Even more fascinating, though, perhaps, if that wasn't fascinating enough, that's a big volcano. Just the cliff off of the escarpment of the Olympus Mons, look at that. That is amazing. That's 8,000 meters, 25,000 feet. That's like Mount Everest on Earth, just the escarpment. Wow. That's pretty amazing. Let's do a new profile here. Let's go ahead and say new profile. Wow. We've got there's so many fascinating things. Let's go ahead and actually select this line, and that's mind-boggling. Again, 20,000 meters, 60,000 feet from the top. Wow. Valles Marineris. Let's take a look at that and do some more measurements. The amazing thing is that, as you can see at the bottom of this, there are numerous partners that made this happen. NASA, U.S. Geological Survey, where I used to work, ESRI, where I work now, Caltech, who we work with on GIS implementation across campus. I recently conducted a GIS workshop for faculty and students. Great people there. And others. But this, oh my goodness gracious. I mean, this looks like sort of a canyon on the Earth, right? But when you measure this, you can see the differences between the Earth and Mars. Again, Mars has some very large features, including the Valles Marineris, one of my favorite features on the solar system. So let's go ahead and just take a profile here. That's 34 kilometers, just from the top of that escarpment to the bottom of the valley floor. And then across 60 some kilometers. You've got feature names on here as well. So we could turn on that. Notice that there's also a latitude, longitude. We'll talk about that in a moment. Notice the latitude and longitude here. You've got Western Hemisphere, Northern, Eastern, and Southern. And so we could go up to the poles and see the landforms there. Let's just go ahead and take an elevation profile here at the Valles Marineris. Again, that's really mind-boggling. Look at that, 10,000. Just right there, almost 10,000 meters. Wow. So again, as I mentioned, you've got the ability to go to different places. Let's look at the Jet Zero Perseverance landing location. Let's go ahead and get rid of that elevation line that we've created. and see why and how big, why the Perseverance landed there, and how big that crater is across with these measure tools, why it was chosen, and so on. So here's the Jet Zero with the Perseverance pathway on it. You can see that the crater itself is a little bit washed out, maybe by lava flows, more recent lava flows after the impact, if that's an impact crater, which it looks like it is. There's a younger one right here. But you can see that it's fairly flat right there, but you can see the landform. Some of this looks, again, like Arizona or Kazakhstan or Uzbekistan in places. But you can see that some of these features are quite a bit larger than anything on the Earth, and, of course, there's no life right there. So lots of differences, but some similarities between the Earth and Mars. But fascinating to teach about scale, about latitude, longitude, about mapping, geospatial information, remote sensing, site selection. Why was this site selected? And, of course, physical features on Mars. And it also points to the fact that mapping is an important tool in lots of different disciplines. We need maps for understanding our own Earth, energy, water, human population, urbanization, oceans, etc., weather, climate. But we also need, wow, look at this. We also need maps and geospatial information for other planetary bodies and other bodies outside of our own solar system as well. But we need maps and information to understand Mars, Ganymede, other planets outside the solar system. Thanks for being with me. I'm just going to measure one more because I just can't resist. This is so amazing that you've got these tools, gracious, at your fingertips. This one is interesting. It's like a double crater. Maybe a newer one here and an older one off to the northeast. This looks sort of like an alluvial fan. It looks like this cliff either eroded or was hit by an asteroid or a meteorite and spewed out debris in sort of alluvial fan-like fashion. Let's just take a look at that a little bit more. Lots of fascinating things to explore. Again, thinking about scale, about positioning. Oh, look at that fissure running across the landscape there. Let's take a look at that again. I had never noticed that one. Look at this. Wow. Look at that. That is amazing. Wow. And then younger impact craters on top of that. I invite you to explore these tools and get your students involved as well. Primary, secondary, community college, technical, tribal college, university levels, after-school clubs. All you need is a web browser, no sign-in, no login required. All you need is a curious mind and a web browser. Thanks for being with me. Get out and explore.